This is Unit 1, Lesson 7, Activity 2. The name of this activity is Sides and Angles. Actually, the name of Unit 1 is Rigid Transformations and Congruence. And what that means is that during a transformation, everything remains rigid. Nothing changes. The sides don't change. The angles don't change. It's just a movement of that image from one place to another. The name of this lesson is No Bending or Stretching. And that's what rigid means. So this is really the lesson that gets at the name of the entire unit. And what we're going to look at right now are sides and angles. So whether that is a translation, which is moving this figure to this figure, or a rotation, which is rotating this figure to this figure, or a reflection, which is reflecting this figure over this line to this figure. The angles in every case remain the same, and the lengths of the sides remain the same. They do not change. They are rigid. So let's look at the first example, which is a translation. So we're going to move figure A to where point P covers point Q. So we're translating figure A to from P to Q. And so there it is. So this is just a movement, 1, 2, 3, 4, 5 units along the x-axis to the right. And notice that the angles remain the same and the length of all the sides remain the same. So it is a rigid transformation. So you can actually measure it. You can import a ruler into Doceri. And so I did that, and so I'm measuring the width right here, which is 2.5 units. That means the width of one square is 1.25 units on this ruler. So the width of 2 is 2.5 units. Then if you just slide this over a little bit, you see that this translates over. That length remains the same. It has to. You can just count the squares, but this is just using a ruler to confirm that. So this is 1 unit, 2 units, and 2.5 units. Okay, rotation. So they used isometric grid paper for this rotation so that they could look at the angles. So this is a 90-degree rotation around this center of rotation, which is point R. So this figure rotates from here over to here. And you can see that this is a 60-degree angle, and then another 30-degree angle. So this equilateral triangle, it's always 60 degrees. Each angle of an equilateral triangle is 60 degrees. And this is half of 60 degrees, or 30. So from here to here is a 90-degree angle. And that then rotates 90 degrees clockwise. So this is the 30 degrees, and this is the 60 degrees. So that's a total rotation of 90 degrees. So that angle remains the same. This angle rotates. Well, actually, now you can't really see the angles. They get somewhat obscured by the grid paper. So one of the things that you can do is I'm going to just make a 60-degree angle down here in Doceri. So I'm going to just draw a line from here to here and from here to here, connect them. That is 60 degrees. And now I can take that angle and slide it up and measure and check if this angle is 60 degrees. This angle we already know is 60 degrees. But I slid it up right here, and that angle is in fact 60 degrees. And then if I slide it over here, you can see that it's half the size. So this angle right here that rotated 90 degrees, it maintained its size. It did not change size. It is still a 30-degree angle. And the length of the sides, this length right here, which is the longer side, this is 6 units long. And notice that the shorter side right here is 3.5 units. So this is 1 unit, 2 units, 3.5 units. So right to there. So once again, it's at 6, and it's 5, 4, 3.5. So it's 3.5 units long. And so now if I take this ruler and I slide it over here, this length should still be 6 units. And this length now on this side should be 3.5 units. So I slid it over here. This length is in fact 3.5 units. It's the shorter length. And the longer length from 3.5 to 9.5 is 6 units. So the lengths are maintained and the angles are maintained. It is a rigid transformation in this rotation, 90-degree rotation. Now another look at this is to do it on normal grid paper. That way you can actually count the sides and you can see that they maintain the same size. So this is a 3, 4, and actually you're going to learn later that this would be 5 units long. So this is called a 3, 4, 5 right triangle. So this is 3 units, this is 4 units, and this is 5 units. We take that, rotate it 90 degrees to the right. This 4 unit side rotates down here, it's still 4 units. And this 3 unit side rotates up here, it's still 3 units. Now what about the angles? Well, on a grid paper, these are all squares, so the diagonal forms a 45-degree angle. So this is 45 degrees to the arrow, and then it's a little bit more than 45 degrees to the side of that angle. Up here, this is actually 45 degrees to that arrow, so this is a little bit less than 45 degrees. These two angles, by the way, have to add to 90 degrees because this angle is 90 degrees. So all the angles of a triangle always add to 180 degrees. So this angle is going to be a little bit more than 45, and this angle up here is going to be a little bit less than 45. This angle over here is going to be a little bit more than 45. And remember, this is the angle that rotated from right here, so it has to be the same size. And this angle down here is going to be a little bit less than 45 degrees. And it's the angle up here that rotated to here. So let's take a look at that. I actually measured them with a protractor. I put a protractor into Doceri and measured the size of those angles. And this angle is 53 degrees, which is a little bit more than 45 degrees. And this angle over here that gets rotated, same angle, still 53 degrees. And this angle is still 45 degrees. So it's a rigid transformation in this rotation. This angle up here is actually 37 degrees. Remember, the two angles have to add to 90 degrees. With this 90 degrees, that would make 180 degrees. A little bit less than 45 degrees. This angle rotates down here, and so it's 45 degrees to here. This is a little bit less than 45 degrees, and it measures as 37 degrees. And the reflection. So I'm going to take this figure and reflect it over this line of reflection, which is labeled L. So the first thing to do is measure or draw a perpendicular line through the points, through the line of reflection. So these lines have to be perpendicular. They have to form 90 degrees. So you just want to know where those lines cross the line of reflection, because then I can place points at each of these intersections, and I can get rid of that extra little part. And so now I'm going to measure A is going to land an equal distance on the other side. Well, you could just use the grid. I just want to show you that you measure this length and you move it over here, and so A prime is going to land over here. You measure this length here. It's 1, 2, 3, 1, 2, 3, and a little bit more than that. So this is a little bit harder because it doesn't land on a line. So I'm going to take this length, move it over here, and take this length and move it over here, and that's going to be 1 unit. So they are moved over. Place a point at the end of each of these, and then do the same thing with the remaining 2 points. Go back and get those. So this is B from the line of reflection to B, and from the line of reflection to D. Now those do not land on intersections at all, so they're a little bit harder. So you can just measure them in Doceri by drawing a line. Move that line over to the other side. So this is the same distance as from the line of reflection to B. That's the same distance as here. Place a point there. And the same thing with the line of reflection to D. Place a point there. And then get rid of those and connect each of the points. So this is a reflected image of this image. This is A prime, B prime, C, D, E prime. And so the point is that these angles remain the same size. Well, B and D are a little bit harder to see. Angle C right here is 90 degrees, and you can be convinced that that's 90 degrees. These two are easy, A and E, because they are both 90 degrees. What about B and D? Well, in Doceri, you can actually draw these angles right here. A little bit hard to see the orange on the purple, sorry about that. But angle B is right here, and angle D is right here. So now that I've drawn those angles, I can actually move them out and slide them over here and see if these angles are in fact the same size. And slide them over, slide them right on top of the angle, and then you just have to rotate it so they line up with the legs here of the angle. If they match, then they are the same size, and in fact they do. So the angles remain the same size, the length of the sides remain the same size. So this is a rigid transformation. No bending, no stretching. It remains the same throughout.